So we talked about combinations when I can have no repeating elements. We go to the pet store and we pick a dog. That dog is no longer in the population. But what happens if I can have repeating elements? If selecting an element out of the population does not remove it from the population. The first idea that comes to my mind is streaming videos. When I'm streaming videos off of Netflix or Amazon Prime, when I select a video to watch, it doesn't remove that video from the pool for anybody else to watch, or for that matter, for me to watch again. So we're going to see that there is another formula for combinations when I can have repeating elements. So if a combination with no repeats could be considered the population of n combinations, choose R, we're going to see that when I have repeating elements, it is going to look a lot like n plus R minus 1 choose R. And so it's going to change my formula. Wherever I find n, I'm going to replace it with n plus 1 minus R. So this will be n plus R, minus 1 factorial. And then there is a R factorial in the denominator. And then I can see that there is an n. I'm going to replace it with n plus R minus 1. And then I'm going to subtract R. And that is factorial. So that will simplify to, so if I remove the parentheses, it simplifies to n plus R minus 1, and ultimately I get n plus R minus 1 factorial over R factorial n minus 1 factorial. So let's say, for instance, that I have a little bit of time on my hands and I'm going to watch episodes of Star Trek. And I have enough time to watch 3 episodes out of season 2 of the original Star Trek. There are 26 episodes in season 2, which means that I am going to choose 3. How many different ways can I watch 3 different episodes out of season 2? Well, given the fact that the order that I watch them doesn't matter, given the fact that watching it doesn't remove it from the population, in theory, I could watch the same episode 3 times in a row if I really, really love that episode. We are going to use the formula for combination with repeats, which means that I'm going to choose n plus R minus 1, choose R. This is going to give me, if there are 26 episodes in the population, I am going to choose 26 plus 3 minus 1, choose R. So if I write it out, this is going to give me 26 plus 3 minus 1 factorial over R factorial, which is 3. And then we're going to say 26 minus 1 factorial. So this is 28 over 3 factorial, 25 factorial. This would simplify to, I can remove the 25s. This becomes 6. 3 factorial is 6. And 26 is going to be 6 times 4, so I can just remove the 6's. And ultimately what I have is 28 times 27 times 4, which is equal to 3024. So there are 3,024 different ways that I can choose 3 episodes out of 26 episodes when selecting it out of the pool, the population does not remove it from the population. A shortcut way to do this, if I'm going to take 26 plus 3 minus 1, choose 3. Another way that I can do this is to take the 28 plus 3 minus 1 and turn that into 28. So that would actually be 28, choose 3, and then I could build it the way that I normally do. That would be 28 factorial over 3 factorial times 28 minus 3 factorial, which gives me 28 factorial over 3 factorial, 25 factorial, which takes me back to the original, which ultimately is going to give me 3,024. So if I choose to do this mathematical calculation first to end up with 28, choose 3, then I can just use my regular combination algorithm instead of having to substitute the original values up here.